là giải nhất, nếu như bạn được giải nhất quốc gia là bạn có thể học lại ở HCMUS từ từng 8 lần. Đấy. Thật ra các bạn được giải nhất quốc gia nếu như có ý định vào HCMUS thì hãy biết được điều đấy, hãy biết được số.
Thay đổi
số mạng sống còn lại của mình là 8 lần. Đấy. Và trước kể là mức học bổng đấy nhé. Mà cái lý do mình biết rõ như thế là do học kỳ vừa rồi có 2 thằng bạn của mình rớt môn.
Đây, bài này thì đầu tiên chúng ta sẽ tới với subtask 1 đây. Để nó cute một xíu. Đây mình có code. Rất là đơn giản thôi. Mình
Giọt nước mắt vương trên khuôn nhà tường ngọc là đã quý anh yêu bà. Tiếng bao anh ta nàng mình dòng mấy bức tranh sơn bào. Có một nụ hồng, chuyện tình yêu có một người chồng. Thật sự yêu ra hoa trăng hoa tính đào. Ok, anh học gần thuộc bài đấy rồi, bài đấy nói chung là anh mới cày chắc được tầm khoảng 5 view cho bài đấy. Nhưng mà mở ngoặc là anh mở ngoặc chính xác là anh không cày view cho pháo. Anh
Nam giúp GSPVSQ mua tranh 10.000 đồng. Smart vừa rồi, Gumayusi khởi động dần được chưa anh?
thì tất nhiên rồi, Gumayusi phải khởi động thôi. Nhưng không có tình hình carrier không ổn lắm. Ôi công nhận hôm nay cái trận buổi chiều nay anh cũng chưa có xem mấy. Trận buổi chiều nay anh chủ yếu xem lướt. Nhưng mà cái đoạn mà Smash hạ được carrier thì pha đấy xem đi xem lại 4-5 lần. Công nhận là không tưởng tượng là pha đấy luôn. Quay trở lại chủ đề sự nghiệp chướng thì chính xác là anh cày được, anh chắc anh mới cày được khoảng 5 view cho bài đấy thôi. Nhưng mà thay vì cày view trực tiếp cho pháo ấy, anh nhớ là anh chỉ cày có một view cho pháo, còn các view còn lại là anh xem của Virus với cả của Missy sao ấy. Anh không nhớ lắm, có 2 người làm reaction cho cái bài đấy là Virus chắc chắn nó có làm, với người thứ hai như là Misty thì anh nhớ là anh nghe của Misty với cả có nghe của Virus. Giọt nước mắt lên trên khuôn nhạc từ ngọc ngà đá quý anh yêu bạc. Thấy bức tranh sơn nhạc là ngầu này ngầu thấy bức tranh sơn vàng. Vốn có một nụ hồng, chuyện tình yêu có một người chồng. Người tôi yêu trăng hoa xa hoa tính đào hoa. Hay cái khác anh gọi em là chướng, hay là chướng ngại chướng mắt là chướng tai. Ngủ nướng cụ thể là nướng khoai. Làm nó biết như thế là quán nai rồi. Cái gì em là nhân viên, em là đối tác, con lợn này trôi ác tôi đó cái gì ra tôi đó anh ta dắt cô ta vào trong căn phòng nhỏ đóng kín. Ở trong phim nô đùa trong trái tim ta thật sự thôi đó. Điều đang nói bây giờ giọt nước mắt vương trên quân nhà được ông cả đã quý anh yêu bạc. thích cái nhưng mà cái bài đấy anh công nhận là lúc đầu anh nghe cái bài sự nghiệp chướng anh tưởng nó chỉ là bài hát bình thường thôi, cho nên là anh không quan tâm lắm đâu. Anh không để ý lắm đến cái bài đấy, nhưng mà sau đến khi mà cũng chỉ nghe lướt thôi, nhưng mà sau đến lúc thấy bảo Virus có cả reaction cho bài diss mình luôn thì quả đấy nghe cũng ghê thật. Ở đây là English livestream. Nói đến English livestream thì từ từ sau anh sẽ quay trở lại nói tiếng Việt nha. Cho nên là nếu bạn nào cảm thấy quá ngán với cả mấy cái livestream bằng tiếng Anh rồi thì yên tâm, từ tuần sau các content của anh sẽ quay trở lại với tiếng Việt. Các bạn yên tâm đi. Còn như là nói thêm tiếng Anh nữa là hôm qua anh mới biết là cái từ diss, cái từ diss trong cái rap diss ấy, hóa ra là nó là từ tiếng Anh. Từ chữ diss đấy là nó viết tắt của chữ disrespect hoặc là nó là xuất phát của cái chữ disrespect. Cho nên là cái diss đây hóa ra là từ tiếng Anh. Chứ lúc đầu anh cứ tưởng cái từ diss đấy là từ tiếng Việt, tại vì là chắc các bạn cũng biết là trong tiếng Việt thì nó cũng có một cái từ, nó cũng có cách phát âm nó khá giống là diss đấy, thì cho nên là lúc đầu anh tưởng cái rap diss đấy là cái diss là nó là từ tiếng Việt đọc chệch ra, nhưng hóa ra nó là từ tiếng Anh. Giọt nước mắt trên quân nhạc từ ngọc ngà đá quý ai yêu bạc, thấy bức tranh hồng nổi bức tranh sơn vàng, vốn có một nữ hồng, người thương biết có một nụ người chuyện tình yêu có một người chồng, người tôi yêu trên hoa xa hoa tính hoa. Nghe thì em biết cô là ai, tất cả biết cô là ai, chỉ nghe không biết em là ai. Vào nhỏ đám kín trong phim, nô đùa trong trái tim ta sắp tới tối đó, chuyện đang nói bây giờ, giọt nước mắt vương trên quân nhạc trường lộc ngà đó. Underground Explorer. Nhưng mà công nhận ấy là các bạn phải biết là trong tin học ấy thì có một cái dạng thuật toán là thuật toán lập lịch ấy. Các bạn ở đây những bạn nào mà đã từng học thì các đã từng học các cái bài về lập trình thi đấu thì các bạn đều biết các cái bài toán về chủ đề lập lịch, hay là bài toán gia công trên hai máy ấy, là những cái loại bài toán nó rất là nổi tiếng ở trong tin. Thì những cái bài toán đó ấy, thì nó đều xuất phát từ câu chuyện lập lịch cả. Tức là đấy, ví dụ các bạn có một cái chuỗi thời gian này, mỗi một máy thì trong một thời điểm là các bạn không thể làm việc này thì không thể làm việc khác được. Thì anh nghĩ là nếu như lúc nào mà anh muốn làm content về chủ đề là bài toán lập lịch ấy thì anh sẽ mời Virus vào làm diễn giả. Tại vì là riêng về cái bài toán lập lịch với cả tối ưu hóa này thì Virus anh thấy khá là khủng. Đấy, để lập lịch được phát lập 8 cái lịch cùng một lúc mà nó đảm bảo là nó không giao nhau mà nó lại ấy được. Mình thấy là như vậy là về tư duy thuật toán của Virus nó rất là cao. Hoàng hay Ngọc là sao? Thực ra là em bảo là em thấy ai đúng nhất thì khó nói lắm, nhưng quan trọng là em cần phải biết là mỗi người thông qua cái video đấy đạt được mục đích gì thôi. Thì cơ bản câu chuyện ở đây là ai đạt được cái mục đích của họ là gì, và nếu như họ đều đạt được cái mục đích của họ rồi ấy, thì nó sẽ là đúng đối với họ thôi. Tại vì góc nhìn cái sự đúng đắn của họ là nó khác với cả góc nhìn sự đúng đắn của mình, nên là câu chuyện đấy khó nói lắm. Nên là đấy, cho nên là nhân tiện hôm nay là sinh nhật Jack đúng không ta? Tại sao hôm nay sinh nhật Jack mình lại nói về Virus? Sinh nhật Jack mà nói về Virus thì không hợp lý cho lắm. Bởi vì nhân tiện ở đây thì có một câu chuyện là nhân tiện ở đây thì cũng có một câu chuyện đấy là có người hỏi anh là theo anh là Jack hay là Virus thì ông nào hơn. Thì nói chung là nếu mà nói về mặt lối sống thì cái này không thảo luận được, với nghĩ hai ông xem nhau, nên là cái này không so sánh ai hơn hay ai kém. Nhưng mà riêng về phần tư duy thuật toán thì Virus hơn hẳn Jack là cái chắc chắn rồi. Jack sau mấy cái vụ đấy thường là flop rất nặng. Mà cái bài hôm nay như Jack mới ra thấy cũng flop mà. Jack đợt này flop chứ còn Virus có flop đâu. Virus ấy lượng view vẫn khá là ok. Virus làm gì mà lật lịch? Virus làm gì mà lật đâu. Hoàng hay Ngọc Virus là Hoàng, còn bạn Kem kia là Ngọc đúng không? Cái gì mà anh nói tiếng Anh suốt đời em ơi, thôi anh là người Việt Nam mà gì mà sao lại nói tiếng Anh suốt đời. Bạn Đông Soriel em có viết thiếu dấu sắc không ta? Cái chỗ mà anh Hoàng em vẫn liêm ấy. Ờ, nhưng mà công nhận á, thông qua câu chuyện của anh tìm mấy bài Facebook hát lại thôi ông ơi, tôi xin ông, hôm trước đã một cái bài kia đã thấy chết dở rồi, bây giờ lại còn bây giờ lại còn tìm mấy bài Facebook hát làm đi, trời ơi, đừng có đừng có ấy nhé. Từ từ, như stream của mình là nhiều, stream của mình hình như là nhiều view hơn stream của Ngọc Kem, nhiều view hơn stream giải đề miền Trung Tây Nguyên rồi đúng không ta? Thôi ít nhất thì ở đây mình cảm ơn bạn Đặng Xuân Minh Hiếu nhiều vì là đã từ bỏ stream ở bên giải đề miền Trung Tây Nguyên để chuyển sang stream này. Nói chung là cái timing của virus là nó chuẩn, và hình như là kể cả cái 2 phút là nó cũng chuẩn, nên là không ai kịp rửa máy quay. Bây giờ bảo Ngọc Kem có bằng chứng thì lấy đâu ra bằng chứng, bây giờ em muốn bằng chứng thế nào được. Thực ra nói về casewalk HH ấy thì nhân tiện đây anh có thể tí nữa anh sẽ chỉ cho các bạn một bài, khi anh chuyển sang bật sang mốt tiếng Anh sẽ chỉ cho các bạn một bài casewalk cực khó chịu. Anh nghĩ là bài này có thể được gọi là bài casewalk khó chịu nhất trên đời mà anh từng làm. Không, thực ra là anh từng đọc đề thôi, vì bài đấy cuối cùng anh kết luận lại là anh làm, tại vì nó quá là khó chịu. Giọt nước mắt hương trên khuôn nhạc từ ngọc ngà đã quý anh yêu bao, tranh sơn nhạc nụ hồng. Cái gì mà chứng dạng clip. Có livestream này anh sẽ chữa các bài khác, nhưng mà được rồi, tí nữa và trong livestream này anh chữa mấy cái bài mà anh đang show ở trên bản này. Mình đang nói cái vụ gì về virus mình quên mất. Rồi, Đặng Xuân Minh Hiếu phải lập lịch trên 8 máy đi em thấy virus lập lịch trên 8 máy còn được cơ mà. Chẳng mà sao hay là trứng ngại trứng mắt là trứng tai, ngủ nướng cụ thể là nướng khoai, nhưng là đích như thế là quán này rồi, em là nhờ nhân viên, em là đối tác, con lợn này chối ác anh. Gì lập lịch trên ca máy á, nhưng mà cái thuật toán lập lịch đấy anh cũng không nhớ rõ lắm đâu, tại vì thực ra nói vậy thôi chứ số lượng bài sử dụng cái thuật toán lập lịch đấy nó khá là ít. Giọt nước mắt vương trên khuôn nhà cường ngọc này đã quý anh yêu bà. Chưa là ok, nghiêm túc. Rồi anh sẽ không pháo nữa, anh thay chuyển sang chế độ pháo, anh chuyện rồi thôi mình sẽ chuyển sang rap văn của virus. Anh trước tới giờ kể từ lúc yêu em là anh yêu em công khai, tất cả những người qua nhà anh đó là vì công việc của anh, tất cả mọi người sang là vì công việc, tất cả mọi người tới đây họ đều biết anh với em yêu nhau, họ cái gì nữa ta, họ đều biết anh với em yêu nhau, tất cả mọi người qua đây họ đều biết em ở đây bởi vì đồ của em để ở đây rất là nhiều. Khi em nói với anh là em không thích những cái đồ đó ở trong nhà anh, là anh đã giải tán đi rồi. Top 3 thứ không nên mang đi học là cái gì? Vim á, Vim thì nó hơi khó, căn bản là kiểu em muốn dùng Vim em phải đi găng vào á. Em phải đi, nhớ là khi mà em dùng Vim ấy thì em phải đi găng này, đeo kính đi găng cẩn thận vào trước khi em bóp, bởi vì là không là cái đấy nó cũng khá là độc đấy nha. Cái mùi nó cũng khá khó chịu, nó phải đeo khẩu trang vào thì mới dùng Vim được. Chứ không thì thực sự là dùng Vim nó khá là khó, nó cũng khá là nguy hiểm, nên là anh công nhận dùng Vim khó. Thôi chuyển nhanh lập tức sang tiếng Anh, không có là mình lại bắt đầu chuyển sang các chuyên mục về virus. Tất cả là anh đi chơi với em, anh hẹn hò với em, anh với em công khai, anh tất cả mọi thứ anh làm là vì em. Tất cả mọi người họ qua nhà anh, đó là đối tác của anh, họ đều biết em qua đây thường xuyên. Tất cả nếu như em bảo em bảo em không thích những đồ đó ở nhà anh đã xử lý gì rồi. Còn khi nào em bảo là em không thích những đồ đó để ở đây mà anh vẫn để nó ở đây, xuất hiện vài ngày liên tục em qua mà vẫn thấy nó nằm ở đây, thì lúc đó là anh không nghe lời em. Còn lại là anh đã chiều theo ý em thấy những cái đồ dùng đó em không thích và anh đã bỏ đi rồi. Alright, so we should move to English, right? Because as I know, if I continue talking in Vietnamese, then I will throw a lot of funny things, and maybe I will get addicted of the song name Sự nghiệp chướng. Do they have Sự nghiệp chướng English shop? Should I look for that? Okay, Sự nghiệp chướng English shop. And shop. Oh my god, yeah, we got English version of Sự nghiệp chướng. Okay, yeah, maybe I will have some reaction videos to these songs, and I hopefully you guys will follow my videos and follow my YouTube channel to see that reaction video. Thank you so much for tuning in here. Alright, so today I will present the solution of another contest from LeetCode. The name of this contest is the biweekly contest 153. Talking about casework problems, and I will give you this problem. Actually, for people who are preparing for the ICPC contest, International Collegiate Programming Contest, then you should be familiar of the casework problems. Even in every kind of ICPC contest, even in ICPC national contest, regional contest in Vietnam and in other country, there might be some casework problems inside the problem set, because you can see that the whole problem set of an ICPC contest consists of 12 to 13 problems. So all the problems in one single ICPC problem set should cover a lot of different areas of the competitive programming, right? And that's why the chance for a casework problems to appear in an official ICPC contest is really high. And one more thing you should know that casework problems are really annoying, because even if you are IOI medalist like me, and if you are very strong coder, if you are a red code force or things like that, you may get stuck on casework problems. But in other aspect, if just a gray coder, a newbie coder can solve the casework problem, because casework problem normally require you to handle a lot of corner case, and the chance for you to miss some corner case is really high. And according to the ICPC rules, even if you miss just one single corner case, you will get wrong answer for some tests, and then you didn't get any point for that incorrect submissions, right? And that's why for casework problems, very strong coder can get stuck with it, while very less experienced coder, or just like newbie, or how can I say, like green or blue coder, they can still get accepted for that problem. Casework problem do not require really strong algorithm knowledge. So most likely case rule problems doesn't require you to know about flow, symmetries, advanced data structure, or even like advanced dynamic programming technique. None of that will appear in will be required to solve case rule problems. But for case, so that's why if even like you are right coder, you know a lot of advanced technique, you know a lot of knowledge in the world, it doesn't help you to solve a case rule problems. And that is the annoying part of case rule problems. And I had to say, one source for you to find some case rule problem to solve is ICPC contest from China. ICPC contest from China. So yeah, as I said before, case rule problems may appear in ICPC contests of Vietnam, Indonesia, European countries, and even world finals. They have a lot all over the world. But for problems especially comes from China, yeah, they are much more annoying, and the high problem, I mean in the ICPC contest, in Chinese ICPC contest, there are much more case rule problems than other official ICPC contests. So let's say I still remember this problem. The name is daylight saving time, I think. Yeah. You got no? Okay, but I'm pretty sure that this one comes from a Chinese ICPC contest, which the name is CCPC. What is that? Yeah, this CCPC finals. As far as I know, the CCPC final here is the official contest to choose the ICPC teams comes from Chinese university who can advance to the world finals. So as you may know, what do you mean by copyright? What happened with the with copyrights? No, I don't think there's copyright issues here. Okay, so if you are if you are a student who are preparing for ICPC, you already know the system of how to qualify to the ICPC World Finals. So our Vietnamese university need to compete in the Asia Pacific region. The Asia Pacific region consists of Korea, Japan, Taiwan, and a lot of Southeast Asia countries, including Vietnam, Singapore, Thailand, Malaysia, Indonesia, and things like that. And all Vietnamese university need to compete against all other countries or other universities in the Asia Pacific region to gain slot in the ICPC World Finals. Especially every year we have the Asia Pacific Championship. So last year it was in February in Singapore, right? Okay. But for Chinese university, all the university in China belongs to other region. This region called the Asia East region. But basically the Asia East region is solely Chinese, solely China. So all the whole China territory belong. So the whole China is from the Asia East region. So that's why the university in China cannot steal any slot of Vietnamese university, or they cannot steal any slot to the world finals of any country comes from the Asia Pacific region. But they have a separate region called the Asia East. And I think every year about 10 or 15 teams from university from China they can advance to the world finals. Okay, and in order to, if you are studying in China and you want to be in the world finals, you need to compete in the CCPC final contest. Okay, so the problem here is daylight saving time. Okay, let's see the statement. All right. So here we have the problem L. The problem L here, daylight saving time, which is okay. Here, yeah, it's pretty simple. Like you have an input which is a timestamp, which is, so for example, this input is like 1 hour 59 minutes 59 seconds in 13th of March 2016. So yeah, you will get some timestamp like this. They have year, month, day, hour, month, hour, minutes, and seconds. And you need to you need to determine if this timestamp belong to daylight summertime, the daylight saving time, or neither or both. So if okay, you can look through Google to see the daylight saving time, so which is the system in some Europe country and even like in the US. So in Vietnam we use the one time zone throughout the year. So we are in the time zone of GMT plus 7, right? Vietnam use the time zone GMT plus 7, and throughout the year at every moment we always use this time zone, the GMT plus 7. But in European countries, they use different time zone in summer and winters. So, for example, in the United Kingdom, they use the GMT. They use the GMT in winter, but GMT plus 1 in summer. So, for example, right now I think it's summer right now. So, for example, this time is 10 p.m. in Vietnam, and right now in United Kingdom it is 4 p.m. So at the moment the United Kingdom is using the GMT plus 1 time zone, which is like it is 6 hours behind Vietnam. So this is summer, and that's why United Kingdom is 6 hours behind Vietnam. And right now it's 4 p.m. because in Vietnam right now it's 10 p.m. But if it was winter, so for example, if it is December during the winter, then United Kingdom will use the GMT time zone, which is 7 hours behind Vietnam. So if during the winter, if right now in Vietnam is 10 p.m., then in the United Kingdom it is only 3 p.m., not 4 p.m. Yeah, that is the daylight saving time. So in the United Kingdom, I think in most European countries and in the US, as far as I know, there might be other country they use daylight saving times, which means that they use different time zone in winter and in summer. The reason why they do that, as far as I know, the reason why they do that, because during summer the sun shines for a very long period during a day. So for example, in let's say in Hanoi, then you will see that every day the sun rises at the sun shines from let's say 6 a.m. to 6 p.m. every day. So like from 6 a.m. to 6 p.m. in Hanoi every day in summer, it is the sun is shining. But from 6 p.m. to 6 a.m. in the next day, then the sky is dark. That is the story in Hanoi. But in United Kingdom and in a lot of European country, during the summer, the sun is shining for a very, very long period during a day. I think that if even like 9 p.m. in summer, you can still see the sun is shining outside. It's really light. And that's why they use different time zone in summer, just to let people wake up, a little bit earlier to enjoy more of the shining time. So just prevent people from sleeping too much. That is the basic idea of why European countries use different time zone in summer. Yeah, just to let people sleep less and wake up earlier in the morning. So that's why they can enjoy more of the sun and they can do more activity in the summer. Okay, all right. So that is the story behind the daylight saving time. And okay, yeah, this is a really annoying casework problem, because you need to know at exactly which moment the country change their time zone from summer to winter, and it depends on the year, I think. Yeah, okay, so in the problem they said that they change from standard time to daylight saving time at the second Sunday in March, and then they change back from PDT to PSD at the first Sunday of November. Okay, so you need to implement all such thing, and it comes a lot of corner cases. I think if you have like 20 if-else commands in your code in order to solve this problem, that is pretty normal. Alright, so if you want to try some case working problem, or if you want to know how annoying they are, just try to solve this problem from CCPC. And as I know, a lot of problems from China, from Chinese ICPC contests are casework, so you need to be aware of that. If you want to have a training with your team and you use some contests from China, then yeah, you need to do a lot of casework. All right, so let's go back to what we are doing here. So today I'm going to present the solution of the biweekly contest 153. Or the problem here I solved it 2 days ago. So before this live stream, I have already solved all the 4 problem from this contest. This is to avoid wasting too much time on debugging the solution and thinking of the solution. So if you have already watched my live stream, my previous live stream on Wednesday, then at that live stream I try to present the solution from the LeetCode weekly contest 444 for exactly this contest. But during that live stream, I waste a lot of time for debugging my solution on one of the problem from this contest, and therefore I did not have so much opportunity to practice my English, and and that's why I make it live stream. So all my live stream this week is in English, and this is for me to have the chance to improve my English skill and my presenting skill. Okay, so for today I choose this contest, and I have implemented all the solution of all the problem here, so that today I just focusing on speaking English and presenting the solutions instead of just spending time writing the code. All right, so we move on, and also okay, I have also recorded the screencast of me writing solving all these problems, and I will upload that video tomorrow. So if you have time, definitely joining me, give me some view to my channel so that I can so that I have more motivation to create nice contents. Once again, thank you for tuning in and joining me for today, and supporting me on this channel. Alright, so I move on to the first problem, reverse degree of a string. We have a string, and the reverse degree is calculated as follows. First, we iterate over all character of this string s, and for each character, we need to multiply its position with its position of the character. So for here, we just determine the position of a character in the alphabet like this. The character A is equal to 26, character B equal to 25, character C equals 24, blah blah blah, and the character Z equals to 1, and for each character we multiply the position of it in the alphabet with the position of it in the string. And for this problem we use the 1 index. So the first character is is at index 1. Okay, and then we sum all of these product of all these characters, then we just got okay. So the first thing is it is definitely literally an easy problem. So the problem just give you some description. They have the definition of the reverse degree, and you just follow what they say in the statement. So first, iterate over all the single characters of the string. For each string, we know the position is I plus 1 because when we loop like this, then we use the 0 indexes. You know that the string in C++ use the 0 indexes, which is like the leftmost character is at the position 0, and the rightmost character is at the position n minus 1, where n is the length of the string. Okay, so we iterate. We have a for loop. I equals 1, and then I plus plus, and I from 0 to from 0 to n minus 1. Okay, and then we just add to the variable rest with this I plus 1 times 26 minus si plus a. Okay, and we got the rest. Yeah. This is just an implementation problem. What is stated in the statement, you do exactly that. You put exactly that in your code, and then you got it. All right. So okay. So move on to the second one. Maximize active session with trade. You are given a binary string s of length n, where okay. So this is a binary string s. You have 1 means an active session, 0 represent an inactive sessions. Well, why do you need that kind of definitions? Yeah, it's not important at all. Okay, so you can perform at most 1 trade to maximize the number of active sessions. So okay, so the aim of this problem is to find the maximum possible number of ones in the string s. Right? We want the number of ones in string s to be as many as possible. And what we can do, we can perform at most 1 change to the string. How the string looks like. First, convert a contiguous block of 1 that is surrounded by 0 to all 0, and afterward convert a contiguous block of 0 that is surrounded by 1 to all 1. Okay, and then we return the maximum number of active sections of s after making the optimal trade. Okay, and we have a note here. Actually, while solving this problem, I did not notice the note. I just completely forget the note. I write the whole code, and then I write the whole code, and when it got some incorrect answer, I just come back and I see that note. So like when I was thinking of the solution, when I was writing the code, I did not notice of this note, and that's why I need to proceed more case, which is a little bit annoying. But anyway. Anyway, actually this is quite a simple problem. Let's see. Okay, the constraint here is the length of s is at most 100,000. So s contains at most 100,000 characters, which means that in this problem you can solve it with the time complexity of O n log n, but not O n square. So if you have a O n square solution, it will be too slow for this, and you will get time limit exceeded. Okay, so here, just give me 1 minute. Where is my... Alright, so here we will have some yeah, I will use some whiteboard for better explanation.
vị trí.
Alright, so here it's the whiteboard. Yeah, it works well. Alright, how can I stop this? Yeah, you can see that in the yeah, we are here, and you can see that in this problem we can make change in the string s by convert a contiguous block of 1 into 0, or convert a contiguous block of 0 into 1. So so that's why we are pay attention to dividing the string into contiguous block of 0 and 1. So you see every binary string, every binary string can be divided into contiguous block of 0 and 1, which means that you have the string may begins with a block of 0, and then a block of 1s, and then a block of 0, and then a block of 1s, and so on. Or in other case, they might be like the first block is a block of 1, and then a block of 0, and then a block of 1s, and then a block of 0. So which means like okay, so let's say if the string s is like 1 1 1 0 0 0 0 0, and then 1, and then 0 0, and 1 1 1 0 0. Okay, if we have a string like this, then we can divide the string into several blocks. So for example, here this is like so we have a block of 3 1s, and then a blocks of 5 0. Okay, it's a little bit. Okay, this is a block of 5 0, and then a block of exactly 1 1s, and then what next? Okay, and then a block of 2 0. Okay, this is a block of 3 1, and finally a block of 2 0. Okay, so so this is a string s, and then you divide it into blocks of 1s, and then the blocks of 0, and then a blocks of 1, and then a block of 0, and then a blocks of 1, and then a blocks of 0. Yeah, this is we have a note. We have a note like this, which is like, okay, you treat the string s as so basically when you solve this problem, you just insert a bit single one to the beginning, and then another one to the end, right? So which means that when you proceed the string s, you can assume that the first character of s and the last character of s is 1, which means like, yeah, which means that you have, okay, for example, okay, so the string s may in the form of this. Yeah, okay, you have a single one at the end. Yeah. Okay, and what can we do in a change? First we find a contiguous block of 1 which is surrounded by 0, and then convert them into 0, which is like, remember, you can only convert a block of 1 into 0 if this block is surrounded by 0. Okay, you can convert a block from 1 to 0 if this is surrounded by 0, which means that you cannot change the beginning blocks or the end block. The first block or the first block and the last block cannot be changed from 1 to 0. Okay, okay, I think I will do it like this, so that you can see my mouse pointer. Okay, please give me all right. Remember that. Okay, we are finished with this problem. So this is the statement, and yeah, just remember this note. The string s always start with 1 and always finish with ones, which means that the leftmost block and the rightmost block contains 1, but you cannot change this block into 0. Yeah. So for example, here you have this block of 1, this block of 1, this block of 1, and this block of 1, but you cannot change this block into 0. If you change the first 3 characters from 1 to 0, this is not possible. And also, if you try to change the last character 1 into 0, it is not possible either. Yeah, you may change this. You may change this from 0 into you may change this, so you may change this character 1 into 0, or you may change this 3 character 1 into 3 number 0. Oh wait, what's happening? Okay, yeah, you can so for the first phase of the modification, when you convert a contiguous block of 1 into 0, you can choose either wait, what's happening with this? Yeah, okay, so this is the letter 1. Okay, let me recap this. On the first phase of the operation, when you select a block of 1 and make it into 0, you can select this block. So for example, you select this block and make it into 0, or you can select this 3 character 1 and make it into 0, but you cannot change this one. So if you try to change the first block from 1 to 0, which is not possible. And also, if you change this block into 0, you change the last block from 1 to 0. It is not possible either. Yeah, you can only change. You can only choose to change the blocks of 1, which is not the first and not the last. Okay. And then after we change, let's see if we change this from 1 to 0, what we get. Okay, if you let's say if we change this from 1 to 0, then we have a new blocks of 0. So now we have the block of 8 consecutive 0. Yeah, let's see if you change the middle 1 into 0, then now we have a block of 8 consecutive 0, right? You have a huge block of 0. Okay, and now for the second phase. Then you convert a contiguous block of 0 that is surrounded by 1 into 1. But yeah, you should remember that they said that you need the block of 0 when we change to 1. Then they have a condition that the block needs to be surrounded by 1. Yeah, you see that. Convert a contiguous block of 0 that is surrounded by 1 to or 1. But the condition that the contiguous block of 0 must be surrounded by 1 is always valid. It's always valid because, as you can see, that the first character of the string is always 1, and the last character of string s is always 1, and you cannot change that 1 to 0, which means that all the contiguous block of 0, they are always surrounded by 1. So which means that now we have the 2 blocks. So now after the first phase of the modification, now you have like this block of 3 character 1s, and then this huge block of 8 character 0, and then another block of 3 1s, and then another block of 2 0, and then another block of 1. So which means that from the second phase, you can see that we try to find the block which the longest block of 0 to change it to 1, right? Yeah, because our target is to maximum the number of 1 in S. Yeah, our target is to maximum yeah, we want the number of character 1 in S to be as many as possible, which means that on the second phase we always choose the block of 0 which is the longest block of 0, or like the block of 0 with the most number of elements. Yeah. Okay, and that's why for the and for this is kind of a brute force solution. So one of the solution we can do is like this. For the first phase, where we choose a block of 1 and convert it to 0, we can iterate over all the possible choice. And for each choice of the first phase, we can try to maintain and we try to find which is the longest contiguous block of 0 obtained after the first phase, and then we do in the second phase. For the second phase, we know for sure that we always try to choose the longest block of 0 to convert it back into 1, which means that our algorithm looks like this. For the first phase, where we choose a block of 0 and make it, for the first phase, when we convert a block of 1 into 0, we can iterate over all the possible choice. Yeah, we have at most n blocks of 1, so we can iterate over all the possible choices. Yeah, we try all possible ways to change a block of 1 into 0, and for each possible choice of a block of 1, then we will try to maintain the longest block of 0 after that change, so that we can find what to choose in the second phase. And for this, you can use a set or multiset. Yeah, we need to use a multiset to find the longest block of 0 in the second phase. All right. Okay. So so for example, here, if as we mentioned above, in the first phase, when we choose a block of 1 and make it into 0, we have two possible choices. The first choice is to make this block from 1 to 0, and for the second choice is to change this block of 3 1s into 3 0. We have two possible choices. For the first choice, we know that the longest block here is okay, so for the first choice, if we change this 1 into 0, from now we have two blocks of 0. The first block contains 8 characters and the second block contains 2 characters. So we know that in the second phase, we will change this block of 8 0 into 1, right? Okay, and that's it. And this is the first choice. The second case is when we change this block from 1 to 0. If we change this block from 1 to 0, what happens? Then from now we have two blocks. Of 0. The first block is 5 consecutive zeros here, and in the second block we have 7 consecutive 0. So this block has 5 and this block has 7. So now we already know that this is the longest block of 0. So we change this block of 7 0 back into 1, and that's it. Okay, so this is our algorithm. First, iterate over all the possible choices of the block to change from 1 to 0, and from that we use a multiset to maintain which is the longest block of 0. All right, and we can see from the and how we can use the multiset to do that. Then let's say in the general case, let's take a general case. Then we have the string S has like it start with one character 1 and finish with another character 1. So so the string S can always be divided into some blocks of character 1, and then some blocks of character 0, and then some blocks of character 1, and then some blocks of character 0, just 0 and 1, and then 0 and 1, and so on. Okay, yeah, the last block is always a 1. Let's put it a little bit smaller. Yeah, okay, yeah, we always have the string S divided by 2 by some blocks of 0, 1, 0, 1, 0, 0, 1, 0, 1 like this. And remember, the first and the last block is always a block of ones. And now we have, and first we store the length of, we use a multiset. We use a multiset and we store all the blocks of 0 into that set. And then when iterate over all the possible choice, when we iterate over all the possible choice of the blocks of 1 to convert it into 0, then we will know something like this. Okay, let's see if we have this is a block of 1. Let's say that the length is L, and before that is a block of 0 with the length X, and after that is a block of 0 which length Y. Then you see that okay, so at some point, if we have 3 consecutive blocks of S, which is like a block of 0 with length X, and then a block of 1 with length L, and then a block of 0 with length Y, then if you change this block of 1 into 0, okay, if we change this block of 1 into 0, then now we will have a whole blocks of 0, which is the whose length is X plus L plus Y. So that's which means that when we try to replace this block of 1 into 0, we just remove the number X from the multiset, remove the number Y from the multiset, and we insert the number X plus L plus Y into the set. Okay, yeah, so remember, we used a multiset to store the length of all the 0 blocks in the string S. And if we change some blocks from 1 into 0, then we got a bigger blocks. So a block of X, then blocks of Y, and the blocks of L. All the blocks now contains 0, which means they merge into 1. That's why we remove the value X and remove the value Y from the set, but insert the value X plus L plus Y. Okay, and this is what I wrote in my first implementation of this code. As I remember, okay, I can see submissions. Yeah, in this for this problem, I made 2 submissions. The first one got time limit exceeded, and the second one got gets accepted. Okay, can I wait? Can I see my code? Oh no! Oh yeah, yeah. I think my code is here. Analyze complexity. Wait. How can I make my code a little bit bigger? Copy into editor. Okay, yeah. This is my first code which get time limit exceeded. And what I hear is like, okay, we have a multiset blocks, and this multiset store all the length of the 0 blocks. All right. First, you can see that. Yeah. This is here. Firstly, I try to divide the string S into a blocks of 0 and 1. Yeah, it is here it is like, how can I divide the string S into the blocks of 0 and 1s? And now I insert all the length of the block 0 into the multiset. Remember, we need to use the multiset instead of a single set, because we store the length of all the blocks 0, and there might be different blocks with the same length. That's why in the set there might be multiple elements with the same values, and that's why we use multiset instead of the set. Okay, and then what else? Okay, this for this one is like we try to iterate over all the possible choices of the blocks of 1 we replace into 0. Yeah, here this is basically like I try to iterate over all the blocks of 1, and I check this is to ensure that the blocks here is not the first one, and it is not the last one as well. And so this is not the first one, not the last one, and this is a blocks of 1. Then I try to change it from 1 to 0. When I change it from 1 to 0, here I erase the length of the previous block, I erase the length of the next blocks, and then I push back here. Yeah, this is what I mentioned here. Like, I need to erase the value X, erase the value of Y from the multiset, but adding back the value X plus L plus Y. All right, so that is what we do here, and from here, yes, and after that we, as I mentioned above, we choose the blocks with 0, and then change it into 1, and we choose the longest block of 0 to change it into 1, and this is, if you may know, this is like the value of the maximum value in the set. You can so R begin is technically, so you see that the begin of a set is the first element, which is like the smallest element, but R begin or reverse begin is the last element of the set, which is the one with maximum value. So this is like the maximum value of the set, and then we basically so okay, so what I'm doing in this line of code is to maximize the variable rest with this selection. So technically I just find the longest block of 0 and try to change it into 1. Okay, and then what I'm doing here is to roll back the set. So here I erase this one, and insert this one into the set. And for this I just roll back or like undo the set, because we will try other choices in this for loop. So like, okay, we make this change we make this change with the purpose of changing this block from 1 into 0, but then we need to roll back this change because we will try another choice of another blocks of 1, and that is my idea here. Unfortunately, I got time limit exceeded because wait, I don't like this. Yeah, I got time limit exceeded because yeah, the multi set is really slow. As you may know, we have a lot of algorithm with the same time complexity of O n logs n, but their constant factors are different. That's why some algorithm with time complexity n log n are very fast, but some other algorithm with exactly the same time complexity are really slow. And multi-set is one of the slowest algorithm with the complexity n logs n. And that's why you can, yeah, okay, and that's the reason why I got time limit exceeded here, even though the time complexity of my algorithm is n logs n. Yeah, here my my time complexity is n logs n, but yeah, maybe I use too many set operation. You can see that in each loops or in each choice in this iteration we have 1, 2, 3, 4, 5, 6. Yeah, 6, or even like we need to call the find operations here. So which means like I use too many operations of the multiset, and that's why the algorithm is too slow, even though the time complexity is n logs n, and by n is at most 100,000, which is pretty simple, pretty small, right? If you see a problem, so what you learn from this case is that when you see a problem with the constraint n is at most 100,000, then you may think that, okay, an algorithm with time complexity of n logs n should always pass the solution. But no, for some algorithm and for some implementation, the constant factor is really high, and that's why you get time limit exceeded. But if you try to optimize the constant factor, if you try to make it a little bit faster, then you will get accepted. Okay. Okay, and what did I change here to get accepted in this problem? So for here, this is the code I get accepted. Okay, what is solution? Oh no. Wait, what's that? Oh my god, they have 996 test cases for these problems. 1000, almost 1000 test case for a single problem. This is huge. Okay, yeah, for the this is the solution where I get accepted. In this solution I just replace the what here I just replaced the multi-set with something I call the smart set. Even though it is not so smart, to be honest, this is not so smart. It is just one way so that I can skip the duplicated values. As I mentioned before, why we need to use the multi-set instead of the set, because we store all the length of the block of 0, which means that there might be some blocks with the same length, and therefore you therefore you need to use the multi-set to store duplicated value or to store different elements with the same value. But here in the smart set, I have an array, a counting array, so that the set values here just store the distinct elements. Okay, the set here just store distinct elements, and when we try to insert different element with the same value, I just increase the count value by 1. So yeah, so technically what I'm doing here is like, instead of storing everything into the set and we need to use the multi-set to store different elements with the same value, I just have an array, a counting array, and then the set just only store distinct value only. And this makes the number of operation of the set much smaller than the previous implementation. Okay, the time complexity of this algorithm for sure, obviously, is still O n log n, but the number of the constant factor of this implementation is much smaller, because the number of insert and erase operation I used in this implementation is much smaller, and that's why I get accepted. I have to say it is not so smart of a solution, but yeah, it is some easy way for you to try to reduce the constant factor of an algorithm to get accepted. Yeah, there are some other way to optimize this code to speed it up, and I think even though, yeah, I think maybe we don't even need to use the set. Even like we can solve this this problem in the linear time complexity, but yeah, just for sure, just for safety reason, I just solve it with n log n's. Okay, this is okay, I think that's all I want to discuss for the second problem, and now we move on to the next one. Okay. Okay, just give me 1 minute. Alright, so this is the third problem, minimum cost to divide array into subarrays. You are given two arrays nums and cost of the same size and an integer k. You can divide nums into subarrays. The cost of the ith subarray consisting of elements num from L to R is okay. Alright, and then return the minimum total possible cost of any valid division. Alright, you can see that this is basically a divide problem. So, this reminds you into dynamic programming. I think if you learn competitive programming, then you may see a lot of problem in the similar form where you have like a sequence of integers, and then you need to divide it into multiple parts. Each part is a contiguous subsequence of the array, and then each element must belong to exactly one part. Yeah, so like you have an array of length n, and you need to divide this array into one or multiple parts, in which each part is some contiguous subarray. Yeah, and for this type of problems, then dynamic programming is most likely the choice. The most is most likely to be the right approach. And this one is not an exceptional. This one is not an exception yet. And we try to solve this problem with dynamic programming. And from here we can see that what? Oh my God! They try to produce a very, very complicated formula of the cost. Okay, so yeah, this problem is like you have an array of length n, and you try to divide it into multiple parts. Each part is a contiguous subarray, and you have a very, very complicated formula to determine the cost of a part. So like the cost of a part depends on which element inside this part, and also depends on the position. Okay. So like the cost of the first part is like this, the cost of the second part is like this, the cost of the third part is like this, and so on. Okay, and then you try to find the way to divide it into parts so that the total cost is as small as possible. Yeah, you need to return the minimum possible of the total cost. Yeah, and this one is for this one, dynamic programming is surely the most the most suitable approach. Okay, let's say how can we solve this with dynamic programming. Okay, all right. Okay, this is biweekly oh my God, biweekly contest 154, problem C. Okay, here you have to divide an array into parts. The cost is if the ith part is from index L to R, then the cost and the cost of this part is the cost of this part is let's say, okay, we have something here. All right, and firstly, let's we index from 1 to n, right? Here they use the zero base index. This is the zero base index, so like the index starting from 0. But for here, just for convenience, I think that most of the times for us, we use one base index, like we index starting from 1 is much more convenient than indexing starting from 0. Alright, so now here if we have two array nums and cost, okay, then okay, we have two arrays, which is nums, and we index from 1 to n. Also cost, we also index from 1 to n. And then we have the divide. We divide into several parts. Okay, if the ith part is from index L to index R, the cost is, so if the cost is the cost is from here. Yeah, we have this is seems to be a very complicated stuff, but okay, we just use that is from we use the index starting from 1, right? Yeah, when we use the index starting from 1, then we got something like this, and then cost L from yeah, we just use L to R. Okay, for then when the cost is like this, then you see that the cost of a part not only depends on the starting and the ending index. Yeah, you see that one part is a continuous subsequence, continuous or contiguous subsequence of the whole array, which is like when we try to determine the part, we have the starting index L and the ending index R, right? But for this problem, the cost of a part not only depends on the starting index L and the ending index R, but also depends on the position of the path, which is I. So like you see, like the leftmost part is like the part 1, the second leftmost part is part 2, the third most part is part 3, and so on. So so from here we have something like this, and because the cost of a part also depends on the position I, we have the dynamic programming forms like this. We let dp or fij be the smallest cost for dividing the first I elements from 1 to I into j parts. Yeah. Or in other words, the dynamic programming state Fij mean that we only consider the first I elements of the array. We try to divide the elements from 1 to I into exactly j part, and Fij is the smallest total cost. The way we try to calculate this is like, first we have Fi1 equal to the cost. Si1 is equal to the cost of the part from 1 to I. Yeah, Fi1, which means that we use exactly one part. We use only one part, so this part must be exactly from 1 to I, right? Fi1 is that we're dividing the element from 1 to I into exactly one part, and that's why this part must be from 1 to I. So for Fi1 is really easy for us to calculate the value. And for Fij, in general, the value of Fij is calculated as this: is Fij equal to Ftj minus 1 plus the cost of the part from t plus 1 to I, and which is the cost j. Okay, here. So which means that Fij is calculated from some Ftj minus 1. The idea is that we have the last part is from the position t plus 1 to the position I, and then this is the jth part. Yeah, we Fij, which means that we use exactly j part. So like the jth part or the last part is from t plus 1 into I, and the previous j minus 1 part is from 1 to t, which is ftj minus 1. And here we have a formula like this. All right, for this formula, for this formula, then we need to further analyze the formula to calculate the cost. Yeah, this is the formula. This is a formula to calculate the cost of a single part. Then from this, I think this really reminds you to the prefix sums, right? Yeah, because I think everyone here are familiar with the prefix sums, and prefix sums is the things you used to calculate the sum of any contiguous part. So let's say when we use the prefix sum, when you use prefix sum, we have, let's see, sum nums I equal to the sum of the first I element of the array num, which is like num1 plus nums2 plus blah 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 plus nums I, or which is sum nums of I minus 1 plus nums I, and then sum cos I equal to cos1 plus cos2 plus blah 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 plus cos I, which is sum cos I minus 1 plus cos I. Okay. Okay, Fij is cost of this. Okay, and then we can change this formula to something more friendly. So which is nums. This one is, what is this one? This one is like sum num r plus k times I, and this one is multiplied by cos r minus cos l plus 1. Some cos r minus some cos l minus 1. Yeah, this is the things. So from here we can use the above formula to see that. So we have the following formula. Okay, Fij here. Okay, Ft j minus 1 plus, okay, for the cost here, which is some num of I plus k times j. Remember k times j because this is the jth part. Okay, yeah. Fij, which means that we use exactly j part, or the last one is the j, the part number j. So this one is k times j, and then this one is multiplied by what else? Some cos. Some cos I minus some cos t. All right. Yeah. We have this one, and exactly this one is like the minimum. So we need to try this like the minimum value of this very long formula, taking that t is from exactly t is from j minus 1 to I minus 1. Yeah, something like this. So like in order to determine the value of Fij, you try all the possible, you iterate the value t from j minus 1 to I minus 1. Then we try to find the minimum possible value of this very long formula. Also, yeah, I think that one thing you should know that when we calculate the Fij here, we must have I is greater than or equal to j. Yeah, this is obviously right, because when we try to dividing I element into j part, then the number of element cannot be smaller than the number of part. We have I greater than or equal to j. So this is here. We have Fij equal to this blah blah blah, and the value t is considered from j minus 1 to I minus 1. Yeah, from this then we have a solution of time complexity O kind of n cube. Yeah, this gives us a solution of time complexity O n cube. Yeah, for we try to calculate the whole dynamic programming array, and this is the two-dimensional array which have n square state, and for each and to calculate the value of each Fij, we need to have a for loop of t. So which means that we have to need another for loop, and the whole time complexity is O n cube. This one is a little bit slow, for the constraint of this is 1000, right? Yeah, the constraint here is the n, or the number of elements of nums, is at most 1000, and because of that the time complexity O n cube, it's a little bit too much, and we got time limit exceeded. For this problem, I also get two submission. The first one also get time limit exceeded. Yeah, for this one you can as you can see that, okay, this is my code, and during this code I have okay, I have this, and from this I also, yeah, this one I use convex hull, but yeah, in fact this is just like a single for loop. So basically this solution which get time limit exceeded here is basically the brute force. So like calculating the value Fij by trying all the possible value of t from j minus 1 to I minus 1, and I got time limit exceeded because of that. But surprisingly, I think surprisingly that I got how many test case passed. Yeah, I get almost every test case passed. So like 745 test case passed overall. The total number of test case is 759. Yeah, almost passed all the test case, and therefore yeah, I get a lot of pass test case. Means that this dynamic programming formula is correct, but the time complexity is too slow, and I need to improve it. Okay, yeah, but surprisingly that an O n cube solution almost pass all the test. Really a big surprise for me. Yeah, an O n cube solution with n is up to 1000, but it passed almost all the test. Okay, then how can we optimize it? In order to get a better solution, a smaller time complexity, we need to get rid of the for loop of t. So like we need to use a data structure to speed up the process of finding the minimum value of Fij. So for calculating the Fij, instead of trying all the possible value of t from j minus 1 to I minus 1, we need to find some more efficient way by using some data structure. And in order to determine which data structure we need to use in this solution, then we need to further analyze the formula of this dynamic programming. Yeah, we need to find some value of t, so that this expression is as small as possible, okay, then now we just writing this and just changing it a little bit. From here we have things like Fij, and then from here we have Okay, yeah, and actually I can change it a little bit so that you can see something interesting. All right, here, this is the expression where we need to find the minimum values of amongst all the possible value of t, and this expression is exactly the same with this one, and we pay attention into this part of the expression. Okay, for this part, for this part, we know that okay, for this part, we know that, yeah, what is the our problem? We need to find the minimum value of this expression, or exactly this expression amongst all the value of t. So like we need to determine which value of t make this value will make this one is the minimum value, and you can see that this part has nothing to do with t. Yeah, we need to choose some t so that the value of this expression is as small as possible. But for the blue part here, it has nothing to do with t, or the value is fixed. It does not depend on t, which means that the t only appear in this first part. Yeah, the variable t only appears in this part, and from that we can see that we need to okay, so here we so from here that yeah, we need to find the minimum value of this part only. Yeah, only this part is related to t. The blue part has nothing to do with t. So like we need to find t, so that so we need to find the minimum value of this one, f t minus j minus 1 minus some cost t multiplied by some num I plus time k and j. Yeah, this one is the important part. And from here you can see that we need to use the convex Hund. We need to see the convex Hund trick to solve these problems. Yeah. From here you can see that this one from this one we can use the convex Hund trick, because for each t we have this part is multiplied with some constant, and this part is just an independent part. So from these things we know that we need to use the convex Hund trick. Okay, yeah, that's okay, so that is the end of the problem, and by using the convex Hund tricks, then we can find the minimum value of this in time complexity of O log n. Actually we can use constant time complexity. So like, yeah, if you optimize this convex Hund trick so that you use the two pointer techniques, then you can find the minimum value of this expression in the constant time complexity. But yeah, for I think that n log n is enough for this, because we have n only 1000, so the overall time complexity of n squared times log n is enough, and that's why we just do like this. Yeah. We can just do it for simpler implementation. I think the implementation of convex Hull trick of time complexity of log n is much more simpler. It's much more simple, so that's why I use this one. Okay, what is my code? What is my accepted code? It is here. Oh, no. Which problem is that? No. Minimum cost. Yeah, this one. Okay, so move on to the very last problem. This last problem is just an extension of the second problem, which is where is the description? This is maximize active session with thread number 2. This one is exactly an extension of the second problem, where you need to proceed multiple queries. All right. So in the second problem, which I mentioned before, you need to proceed it just in a single string. So you have a single string s, and you want to maximize the number of ones in string s using this operation. For this, for the problem D, or for the last problem, exactly the same operation. You also have a binary string, and you also need to maximize the number of one inside it. However, here you have multiple query. Each query is just a substring of the original string. So like you have an original string s, you have multiple queries. Each query is a contiguous part of this string s, and you need to solve the original problem, how to maximize the number of ones inside this part. Yeah, from L to R. So here you can see that in each you are given an 2D array queries, where each queries is basically each queries here is a pair of integer L and R, and in each query you need to consider only a contiguous part. And how many queries? Yeah, you have 100,000 queries in one test case, so you need to proceed 100,000 queries. Okay, then actually the idea of this problem is quite simple. So from the second problem, yeah, luckily I still give this I still have this figure, so that I can explain this more clearly. Then all right, so from here, the idea is that you divide the string S into several contiguous blocks of 0 and 1s, and okay, you have several blocks of 1 and 0 and 1 and 0 and 1 and 0 and 1 like this. And exactly you can see that as I mentioned above, the operation, the change you can make here consists of two phases. The first in the first phase you change a contiguous block of 1 into 0, and on the second phase you change a contiguous block of 0 into 1. And actually from this operation you can choose two consecutive blocks of 0 and then put it into 1. Okay, you can figure out it in this like this as below. Okay, so yeah, we have some block of 1. And in the middle of the blocks of 1, you have some block of 0, like here, and then here, and then here. Okay, and when we have two phases, right? The first phase is when we change blocks of 1 into 0, and the second phase is changing a block of 0 into 1. So what you can do here, so for example, if you change on the first phase, you change this block from 0 into 1. So for example, if you choose this block and change this from 0 into 1, then you will have a huge block of 0 like this. So like from now we have a whole block of 0, which is like the total, like the merge of the three consecutive blocks. This, all are now 0. So you have a huge block of 0. And now on the second phase, you can change this block from 0 into 1. So now you will have the whole blocks here is like 1. So in summarize, for the two phases of this operation, then now you have this block from 1 finally is still 1, but this block, it is initially 0, but now it's changed into 1, and this block initially 0 and now it's changed into 1. So that is what you can see, yeah, for one in one operation. Yeah, so the first phase, okay, so let me recap this a little bit. Yeah, in the first phase you choose some blocks of 1 and then replace it into 0. So like for example, if you choose this block and then change it from 1 to 0, then you will have something like this. And from now you will have a huge block containing 0. And then in the second phase you choose this block to change it from 0 into 1. Then at the end you have all of these are 1. So like this block is also 1, this block is also 1. This part, first initially it is 1. In the first phase it changed from 1 to 0, but then in the second phase it changed back from 0 to 1. So finally it is still 1 like at the beginning. So like, yeah, so what is actually changed after two phases, which is this block and this block. Okay, yeah, this block initially 0, but finally it is 1. This block initially 0, but at the end it turns into 1. So like you can see that in one single operation you can change two consecutive blocks of 0 into 1. So that's why in order to make the number of 1 at the end as much as possible, we need to choose two consecutive blocks of 0, so that the total number of 0, or the total length of these two blocks, is maximum, is as high as possible. Yeah, that is the key. that is the key observation of this problem. Yeah. So basically you from this you need to proceed some corner case. You need to proceed some corner case of this, because this one is like processing queries. But yeah, the general idea is that you divide the string into continuous block of 0 and 1, and then you in one operation you can choose 2 consecutive blocks of 0 and then make it into 1. So that's why so in order to make the number of 1 as high as possible, you just choose 2 consecutive blocks so that the total length is maximum. Yeah. Okay, so from now is the time for case working, for case handling. Yeah, you need to handle several cases, because each query from each query is like this. At the beginning you are given a string s. We can modelize, we can represent the string s is something like this, and in each query you proceed only some continuous parts of s from L to R, like this, from L to R. Okay, so and we need to divide this part from L to R into several blocks of 0 and 1s. So like this, 0 and 1s, and 0 and 0 and 1s here. All right, you need to proceed several things like 0 and 1 and 0 and 1 like this. So as to yeah, so and then you need to find the 2 consecutive block of 0 with the highest total length. And and one corner case you need to handle is this: if there is only 1 block of 0. So let's say if the part from L to R looks like this, some blocks of 1, then some blocks of 0, and then some blocks of 1, which means that if there are exactly 1 blocks of if there are exactly 1 blocks of 0, then you cannot make any change. Yeah, because what is stated in the statement, in the first phase you need to find a contiguous block of 1 which is surrounded by 0. But if the string looks like this, then all the blocks of 1 are not surrounded by 0, which means that you cannot perform this operation. Yeah. Okay, so this is one special case you need to pay attention to. Yeah. If there is only 1 block of 0, then you cannot make any change. That is the first special case. And then there are some other special case where you have, for example, if the character at the position L or the character at the position R are 0, then there might be some blocks of 0 at the beginning and at the end of this query part. In each query you handle only 1 part from L to R, and this part may start with 0 or may end with 0, and therefore you need to do something with this special case. And also in general, you can use some range minimum queries or segment tree just to find the 2 consecutive blocks with highest total length. Okay, yeah, and that is the basic ideas. And for all the case you need to handle, that you need to pay attention to it, so as not getting a wrong answer for this. Okay, I think that's the end for now. This is the solution for all 4 problems. I have another video where which is my screencast of solving and writing the solution for all the 4 problems. I will upload it tomorrow, and hope you can have some time to see it. Okay, and thanks for watching. Hope you guys enjoy it, and see you in other videos.